So hi everyone, welcome back to my channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So in this video we will see what are different patterns of recursion. Yes, you heard it right, recursion. We all are very used to learn this and memorize the code whenever we come to this topic, because recursion we all feel that it is very hard. By the time we are solving arrays and string problems, we all are comfortable with DSA, but when recursion introduces, this becomes hard. We all have been said कि make a call stack diagram and recursively call the functions. But that is not actually recursion means. Recursion is not only calling a function itself, but it is about depending or relying onto another function which will surely bring us smaller answers. So as per our rule, let's see what is recursion and why recursion is needed, and then we will start with our basic patterns in recursion. As said, recursion is not only about calling a function itself, but it is about trusting the solution for a smaller problem which will be done by the function itself. Means you break a big problem into the same problem but with a smaller input. And every recursion function has two things. First is base case and second is recursive call. Base case is where our function stop. Means we save the function from going into infinite loop. And second, recursive call means we are breaking down the same problem for the smaller inputs now. And these two things are very important when we are learning recursion. Let's take an example problem of factorial number here. So we will solve the factorial with the help of recursion. We all know the definition of factorial. When we say 5 factorial, we basically mean to say 5 into 4 into 3 into 2 into 1. Basically, we bring the multiplication of all the numbers from 1 to that particular number n. So if you see here, 5 factorial means 5 into 4 into 3 into 2. So we will consider this 4 into 3 into 2. Can we say this 4 factorial? Yes, we can. So this is what we will mention in the recursive call here. For 5 factorial, we will bring 5 into the same function call for 4 now, and 4 is nothing but 4 factorial function. Now function 4 means 4 into function with 3, and again 3 means 3 into function for 2, and now for 2 also we will call 2 into function for 1, and for function 1, 1 into function 0, and for 0 we know the factorial of 0 is 1. So here is the time where we have to write the base case. So in the base case we write if this n is equal to 0, then we have to return 1. So basically we are saving our function call from infinite loop, and at the time when our n is equal to 0, it will not stuck in the same function call anymore, but it will return 1 here, and when the 1 will be returned to function 0, so now the answer will be 1 here, and 1 into 1 it will return 1. So this function will get 1. Now 2 into 1, 2, it will be returned to function 2, and function 2 will have value 2. Now 3 into 2 will have 6, and this 6 will be returned to function 3. Now 6 into 4, 24, and this 24 will be returned to function 4, and now that the last 5 into 24 means 120 will be the final answer. So this is what recursion means. Now the question is why recursion is needed. Recursion is needed in every case where we talk about tree data structure, graph, backtracking, etc. So this is very important to learn recursion, and recursion is not any data structure here. Recursion is an algorithm which we use to solve multiple problems, and especially used in dynamic programming. Now you all will be thinking that recursion is simple na, base case and recursive calls, that's it. Now why we want to learn pattern here? Patterns are there in the recursion, yes. And there are different patterns: linear recursion, divide and conquer, multiple recursions on string, etc. And that we will be seeing in this video. So without wasting any time, let's start. Now our first pattern is linear recursion. Linear recursion simply means where we are calling our function for only one time. Means suppose in case of factorial, in previous case we have taken the example of factorial. So for 5 factorial we call the function for 4, correct? So basically for every function for n we are calling the recursive function for n minus 1, and for every function when we are calling a simple function, this is called recursion. So when you will make a stack tree for this is how it will look like. For 5 it will be function for 4, now for 4 it will be 3, for 3 it will be 2, and so on. So it looks like in a linear form. So this is why it is linear recursion. And from this pattern you can solve problems like first factorial of a number, or you can do reverse a string, or you can print the summation of n natural numbers, etc. So remember, if the stack trees looks linear, so it is called linear recursion. And this is the basic pattern of recursion. If you are starting with recursion, you always start with this first pattern and try solving all these questions first with the stack diagram in your copy and then only move to the another pattern. Now the second pattern is divide and conquer pattern, and the simple rule for this is if you can break a problem into two different problems and then combine back to get the final answer. Remember, breaking and combining back to final answer, that is called divide and conquer. And if you have learned the merge sort algorithm earlier, then you can properly relate with this algorithm. So wherever divide and conquer is required, especially you will see in merge sort, binary search algorithm, or you can also see in the tree type of questions. Like suppose you have to bring the left subtree sum, right subtree sum for that node. So for this you have divide and you have called the recursive function. And after bringing the sum, you have to do the summation of left subtree sum and right subtree sum, and then you have to return. So there you are combining it, conquering it. That is why it is called divide and conquered based recursion. And remember, this type of recursion takes logarithmic time complexity instead of linear. You can solve problems like binary search. In binary search, how we call for the left function when the number is smaller, or how we go to right side when our target value is greater than mid, etc. Second is merge sort algorithm. Merge sort is similar to this. You can solve it linearly as well, but you can solve this divide and conquer with recursive call function instead of incrementing or decrementing your pointer in the while loop or for loop. Third will be mostly in trees. You will see this where you have to call for the left side and right side, bring the answer and make a decision, suppose it is true or not. Or it can be about the computation also, ki add your left subtree and right subtree summation and return it, etc. So wherever we are calling multiple functions, either it is two or more than that, and then combining the answer back from that call, that is called divide and conquer pattern of recursion. Now the next very important pattern is recursion on a string. It is another pattern just because of we are applying the recursion on a string not only for the recursive call but to compute or decide something. Means suppose you have been given a question like you have a string and you have to check that if the string is a palindrome or not. And the definition of palindrome is its first character and last character should match, AA. Now its second character should match with the second last, BB. And the third character and third last character should match, yes. If it is matching, then it is a palindrome. And suppose we have to solve this with recursive function. So in the function, we will simply send this a string and a left pointer and right pointer. And here we will check ki if our S of left pointer is not is equal to S of right pointer, then we will simply return false, saying ki this is not true. So this is our main condition check. After this, if this if case is not running, means left pointer value and right pointer value means character are same. So in that case, instead of doing L++ and R-, we will send these two value in a function. Means we will call the same function S with L+1 value and R-1 value. And whatever we will get, we will simply return it. So this is what we are only calling one function. So this can be linear, and if you will draw the stack also for this, so the stack will also look like linear. So L will be 0 index and R will be 0, 1, 2, 3, 4, 5. Correct? So after this, if we will call the second stack, our second stack will have value S, L will be +1 means 1 and minus, and right will be right -1 means 4. Now this will call the next function because our second character and last second character are matching. After this, we'll call this same function with L+1 means 2 and R-1 means 3. And again here the third character and last third character are matching, so again it will call a function. Now for L+1 means 3 and R-1 means 2, and at this time we can say ki L has crossed R, means we don't need to check the left value A and this right value A because we have already checked it. So here we have to add a base case here. So here we will add if L is less than R, then only continue, or else just return from the function saying ki we have crossed it, and return with the value true, because if you have crossed it means you have checked every character and all are matching, means a palindrome. So the stack looks linear. So it is a type of linear recursion, but why it has been added in a different pattern? Because applying recursion on string is not only about the calling to the function, but going there and then deciding the answer, whether it is true or false. And it can be some computation as well. And that is why recursion on a string is different pattern. Problems like palindrome check, remove characters, or different ways to add parentheses, etc. will fall under this category. So mostly all the recursive type functions from the string where you are using a single call function, we will consider this in a recursive of string pattern. And the last pattern is recursive stack and linked list. A recursive stack, we have seen this in the stack pattern as well. If you have not watched that video, I'll add it here on the link. You can check it out. Recursive stack or linked list. Basically, you can reverse the stack or reverse the linked list already, but we have not learned how to do this in a recursive call. And why this is needed? Because suppose you have a stack and you have numbers like 1, 2, 3 and 4 and you have to reverse it. So to reverse this, you need another stack where you will be popping from stack 1 and pushing in stack 2. So first you will pop 4 and push in my stack 2. After this you will pop 3 and push in stack 2. Again you will pop 2 and push in stack 2. Again you will pop 1 and push in stack 2. This is how you will reverse. But for this reversal, you have used an extra space complexity to create the extra stack called stack 2. And through recursion, it saves your extra space complexity. Means while calling through the recursive function or going till the tail of that function, we are not doing anything. But while coming back, we will put in recursive order. I will not show you the code here because then it will be a very lengthy video. I'm just telling you how recursion on stack and linked list can be a different pattern. So basically, it's not about only this data structure. Wherever you have been told to manipulate the data structure, means a stack, a queue, linked list, etc. through the help of recursion, it always meant to save your extra space complexity there. And problems like merge to sorted list, which you have done in linked list, we can do this via recursion as well. And suppose you have been set to delete the last element in the stack. So to delete the first element, you just have to pop the element. But to delete the last element, you have to recursively call to the last element and then you have to remove 4. And then again, when you are recursively going back, you will put 2, 3 all elements again back in the stack. This is only possible in recursion because in recursion you don't need to call any extra or use any extra space complexity or data structure. So these were the 4 patterns so far, and let's see what we learned now. First pattern we learned was linear recursion. So whenever we are calling the function and reducing by 1 and the structure, the stack structure looks like linear, so that is a part of linear recursion. Second was a splitting problem. So whenever we divide the problem into 2 or more than 2 subproblems, or we can say first divided and then combined back, which is divide and conquer. So this pattern is called divide and conquer. Then third, we learned about string plus choices. So whenever we are applying recursion on a string to get something, it can be a linear recursion also, but why we have categorized a different pattern? Because the whole methodology and idea behind the recursion is very different. So it will be string recursion. And last is stack and linked list. So basically when we apply recursion on a stack to solve problems like reverse the stack without using any extra space complexity, or remove the bottom element of the stack or middle element of the stack without using any extra space complexity, all these will come under recursion on stack and linked list. So remember these 4 patterns of recursion and trust me, practice the pattern wise question which I have already mentioned in my sheet. I can show you here. Here you just need to go and practice the questions as per the pattern wise. You will be able to do the at least medium level of questions or even hard from tree or graph or most important dynamic programming, because without recursion these data structures means nothing. So I hope this video was helpful and do share with your friends who might need this. And if you want to learn recursion per question or per pattern in depth, do let me know in the comment section. I'll surely try to bring the new videos on these questions and basically targeting our sheet which we have mentioned already in the description below. So you can surely do check out, and let's meet in another video. Till then, keep learning, take care of yourself and your family.